In this video, we will be learning about a simple transmission gate, how it works. Here is a schematic of a transmission gate where we have a Pmos transistor on top and Nmos transistor at the bottom. And for a Pmos transistor, we have to give the control signal in its inverted form. For an Nmos transistor, we have to give the control signal directly. We have to club these two together, both Pmos and Nmos together, and feed in the input so that we will have the output on the other side. So always this side will be input, on the other side we will have output. It can be interchangeable. For an Nmos transistor, we are giving the control signal as such, and inverted version of control signal for the Pmos transistor. This is a circuit schematic, and for this circuit schematic we also have a symbol where we will have two triangles connected in this fashion. On top always we have Pmos transistor, therefore the bubble is on the top. On the bottom we don't have anything because it is simple an Nmos transistor. So for an Nmos we will be giving the control signal C. For Pmos we will be giving the inverted version of the control signal. On one side we will be having the input A, on the other side we will be having the output B. So here is a truth table. If the control signal is 1, what happens to C bar? C bar will be automatically 0. When for an Nmos transistor, when we pass 1, for a Pmos transistor, when we pass 0, both the transistor switches on. When both are on, whatever is in input will be traveling to the output. If it is 0, the output will be 0. If it is 1, the output will be 1. That is what given here. If the control signal is 1, Nmos transistor is on. When C is equal to 1, obviously C bar will be equal to 0, therefore Pmos on. When both the transistors are on, whatever is in input will be at the output. If the input is 0, output is 0. If input is 1, output is 1. On the other hand, when the control signal is 0, obviously C bar becomes 1. When we feed in 1 to a Pmos transistor, it will switch off. Similarly, when you feed in 0 to an Nmos transistor, that will also switch off. So both will switch off, resulting in switching off the complete transmission gate. Therefore, whatever inputs you have, it will not reflect at the output at all. This is a simple functionality of a transmission gate. The same is being explained here in detail. When the control signal is 1, C bar will be automatically 0, Pmos transistor is on, and Nmos transistor is also on. So what happens? Whatever is in input will be traveling to the output. What is the advantage of using transmission gate? When we use a simple Nmos pass transistor, what happens? Here is a control signal. Here we have the input and as well as the output. When the control signal is equal to 1, pass transistor switches on, porting whatever is in input to the output, therefore output will be equal to A. But what was a disadvantage of a pass transistor? This Nmos transistor can pass a strong 0, but it cannot pass strong 1. On the same hand, if you use a Pmos transistor, similarly we have the control signal. When it is equal to 0, whatever is in input will be transferred to the output. So output B will be equal to A. But what is a disadvantage of this Pmos pass transistor? It can pass strong 1, but it cannot pass strong 0. Both the transistors being separate and separate, there were disadvantages. We started to club together. We have a Pmos and as well as Nmos. Pmos passes strong 1, Nmos passes strong 0. When we club these two advantages together, what happens? There will be no degradation of signal at the output. So the other half here, when the control signal is 0, C bar will be automatically 1. Therefore, this TG is switched off. This is how a simple transmission gate works. What is the advantages? There will be no signal degradation as we have seen. What is a disadvantage? For every transmission gate, if you draw, how many signals you need? Anyhow, we'll have your input and as well as output. So we'll have input and output. But instead of one control signal called C, you always need the complemented version of the control signal, which is C bar. For every transmission gate, we have two control signal, one in its original form and one in its inverted form. This is one disadvantage. And similarly, for implementing one simple function of transporting your input to the output, in case of your pass transistor, what did we do? We had only one transistor, maybe NMOS or PMOS. But in case of TG, what we are going to do? We have both NMOS and PMOS. So for the same function, instead of one transistor, we are using two transistors. Therefore, number of transistors are increasing when compared to pass transistor logic. This is another disadvantage. Hope the explanation, advantages and disadvantages all are clear now. Thank you for watching.